Welcome to the Blender Pro Hair Suite add-on, version 1.1 tutorial. This tutorial is divided into 4 sections. Section 1, Cards to Curves Workflow and Ready Node Presets. Section 2, Curves to Cards. Section 3, Hair Curve Selection Tools. Section 4, UV Island Separator Use Cases and Detailed Operator Breakdown. Let's begin with Section 1. As you can see, we have a hair card model that has been separated into 5 parts. This setup is useful for optimization and will make the workflow much easier later in the process. To start, we'll perform a random mesh deletion pass. Since some hair cards overlap, we don't need every single card in the conversion process. You can remove a percentage of the cards while maintaining the overall hairstyle shape. For example, setting the delete ratio to 0.25 typically reduces density without noticeably affecting the final appearance. Once that's done, click Cards to Curves to begin the conversion process. The add-on automatically generates a batch of curves from the selected hair cards, and each hair card is converted into its own strand group. This organization becomes especially useful later in Section 2. At this stage, we're aligning the hair roots to ensure a clean and consistent foundation for the generated curves. After completing the alignment for this part, we'll temporarily hide it and continue with the remaining parts. Since this process is repetitive, the video will be sped up during the remaining conversions. Once all hair card sections have been converted to curves, you can hide the hair roots visualizer and join all generated curve objects together using Ctrl+J. Now let's move on to the Ready Node presets. First, you'll need a character head or scalp to serve as the target emitter surface. Open the preset menu and load the first preset from the download icon with the name Cards to Curves. After loading the preset, locate the Cards to Curves node group and enable the Self-Check button. Within these nodes, you can adjust curve point count, strand count, curve radius, duplicate settings. These controls allow you to increase density and refine the overall appearance of the hairstyle. Further down the node tree, you'll find controls for strand displacement. Some nodes may be muted by default. Simply unmute them when needed. For collision handling, assign your character's scalp as the collision object. You can then adjust the collision distance and related parameters to achieve the desired result. The root snap controls help ensure the generated hair remains properly attached to the scalp, resulting in a clean and natural-looking base. You can also add other geometry nodes or stack additional presets on top of the existing setup. Let's add a curl node as an example. Another useful feature is that the preset automatically loads a ready-to-use hair material. In the Material tab, you'll find controls for root-to-tip gradients, color adjustments, shading variations, additional stylistic customization. This allows you to quickly achieve production-ready results without building a hair shader from scratch. Once you're satisfied with the hairstyle, you can proceed to simulation. The simulation preset automatically includes reduced hair optimization, a resample curve node. It is highly recommended to keep the resample node enabled. Hair curves often contain uneven point distributions. The resampling process normalizes the point count across strands, resulting in a more stable and predictable simulation. Let's run the simulation and examine the results. For better performance, you have 2 options. Apply the previous Cards to Curves modifier once you're finished editing, or, for a more procedural workflow, bake the generated curves. To bake, open the Geometry Nodes modifier and select Bake Still. After baking, disable the visibility of the Cards to Curves modifier. This significantly improves playback performance during simulation. Before testing further, let's create a simple animation so the simulation effects are easier to observe. Within the simulation controls, you can specify collision objects, full object collisions, external force influences. For example, if a character's hand needs to interact with the hair, you can assign that object as a full object collision source. You can also create wind effects by assigning a guide object and using it as a directional influence. Keep in mind that the scale of the guide object affects the strength of the wind force. Once you're satisfied with the simulation, you can disable the reduced hair option and bake the full resolution result. You may either bake directly through the physics simulation nodes or bake through the geometry node's bake node. Currently, Blender does not expose a Python-accessible baking API for the geometry node's bake system, which means this process cannot yet be fully automated within the add-on. After baking, you'll be able to preview the final hair simulation in real time directly inside Blender, and that's it for Section 1. Now for Section 2. With the curve selected, navigate to Hair Converter's Curves to Cards. By default, the naming mode is set to random, but for this workflow, I strongly recommend switching to custom. The random option creates a separate vertex group for every generated strand. While this can be useful for advanced workflows, it can quickly become very heavy on larger hairstyles. Instead, switch to custom naming. For example, ID, front, suffix, left, then click Convert to Hair Cards. The selected hair curves will now be converted into hair cards. During the conversion process, the add-on automatically generates UVs and creates the required vertex groups. This includes the custom group name that we assigned, along with the roots and pins vertex groups. If we join the generated cards using Ctrl+J, you'll see the following vertex groups: roots, pins, front_left. The custom group name is preserved and stored as a dedicated card group, making it easy to identify and work with different hair sections later on. This conversion process is repetitive, so we'll speed up the video and continue once all sections have been converted. Now that all hair curve groups have been converted, we can select all of the newly generated hair cards and join them together into a single object. If we look at the Vertex Groups panel, we can see that every generated group is still present. We have roots, pins, individual card groups created during conversion. Each custom group name that we assigned during the Curves to Cards process has been preserved, allowing us to isolate and edit specific hair regions whenever needed. Now let's look at the Ready Node preset workflow. The main difference between Section 1 and Section 2 is the setup of the Cards to Curves preset. In Section 1, we enabled the Self option and used the generated curves directly. For this workflow, first select the scalp object and click Attach New Hair Curve to create a new hair curve object. Next, add the Cards to Curves preset. Instead of enabling Self, switch the source mode to Object and select the newly generated hair cards as the source object. The preset will now generate a separate hair curve object using the hair cards as a live reference. This means that any modifications made to the hair cards will automatically update the generated curves. For example, if we add a smooth modifier to the cards, the generated curves will immediately reflect those changes. Likewise, if we move, reshape, or edit the cards, the generated curves update automatically. Any vertex groups stored on the cards are also available to the generated curves, allowing all group-based operations to remain fully synchronized. Other than this setup difference, all Ready Node preset functionality remains exactly the same as in Section 1. The material workflow, simulation workflow, and procedural controls all behave identically. One thing worth mentioning is what happens when the Cards to Curves modifier is applied. When applying the modifier, all generated attributes are written directly into the resulting hair curve data. This includes information such as card groups, crease edges, root data, pin data. Instead of being stored only inside the geometry node's modifier stack, these attributes become part of the actual hair curve object itself. Finally, if you ever need to convert these resulting hair cards back into hair curves, all stored information is preserved automatically. The add-on stores the root direction and conversion data during the process, allowing you to move back and forth between hair cards and hair curves. Now let's move on to Section 3, the Hair Curve Selection Tools. As you can see, after applying the Cards to Curves modifier, all of the vertex groups from the hair cards have been transferred to attributes on the hair curves. To load those attributes into the group selector, simply click the Refresh button. As you can see, all available attributes are now displayed inside the group selector. Now let's switch to Hair Sculpt mode. From here, you can quickly select, deselect, or remove groups directly from the group selector. You can also create your own custom groups. For example, in Control Point Selection mode, we can select a set of curve points and create a new group from that selection. After assigning a name and creating the group, it immediately appears in the group selector and becomes available for future selections. The same with the curve selection mode. Make a selection and create another group in exactly the same way. Another useful feature is Create Colors. When enabled, each group is assigned its own color attribute. As you can see, every group is now displayed with a unique color, making it much easier to visualize and identify different hair regions. You can also customize these colors however you like. These color attributes can be used later inside materials, allowing you to create custom shading effects, masks, color variations, or any other group-based material setup. Another feature of the group selector is the ability to import existing curve attributes directly into the selection system. For example, we can import the roots attribute. Once imported, we can instantly select all root points from the hair curves. From there, you can use standard operations such as inverse selection or create new groups based on that selection. And that's it for Section 3. Now for Section 4. In this section, we'll go through the UV island separator tools and a few operators that we haven't covered yet. Most of these tools are designed to help fix, debug, and prepare hair cards before conversion. First, we have Separate by UV Quad. This operator uses the UV layout to split larger hair cards into smaller individual cards. This can be useful before converting cards to curves, since more cards will result in more generated curve strips and give you greater control over the final hairstyle. Next, we have Bound Non-Cards. This is mainly a debugging tool. If a hair card contains invalid UVs or geometry that doesn't match the expected card structure, the add-on creates a bounding box around the problematic area. You can then use Select Bounds to quickly locate and inspect those cards. For Rectify, if your UVs become distorted or skewed, this tool helps straighten them and restore a cleaner card shape. For Ensure All Quads, the operator checks the mesh and attempts to convert problematic geometry into a valid quad structure. Since it may modify or remove geometry in some situations, it's a good idea to review the results before continuing. Next, we have Fix UV Rotation. Hair card conversion relies heavily on UV orientation, so the UV islands should generally be aligned either vertically or horizontally. If they aren't, the conversion may not produce the desired result. This operator automatically corrects the UV orientation. For Restore UV Mesh, this operator is designed to reconstruct split or damaged hair card meshes using their UV information. Unlike a regular weld operation, it uses the UV layout to determine how the mesh should be restored. Depending on the asset, you can also use options such as separate by parts or separate by UV similarity. Finally, there are a few cards to curves options worth mentioning. The UV tolerance setting can be adjusted when working with imperfect UV layouts and may help improve conversion results. If a generated curve ends up facing the wrong direction, simply use flip direction to correct it. And that's it for the Blender Pro Hair Suite tutorial. Thank you for watching, and I hope you enjoy using the add-on.